Today I want to show you how I make the neck of the guitar from my previous video. Let me show you the CAM process. It all starts of course by selecting the stock. I've selected the neck as main body, but also selected 4 circles on a sketch plane. These circles are for the dowels. Later I can flip the stock, put dowels into place and do the other side. I've entered the dimensions of the stock as well, so Fusion can place the neck in the center of the stock. The origin of the stock is center top. For the other side I will use the same point and flip the Z-axis, making sure it's pointing upwards. So I turn the stock around the Y-axis. I then start a drill process. It drills the 4 holes for the dowels. They go 10 mm down into the material. Please note that they go down 10 mm from the same height as the neck. The stock, however, is even 2 mm thicker, so the total depth will be around 12 mm. That is totally fine for the purpose of holding the dowels in place. Then, to get a flat surface at the top of the stock, a face process is started. It has an overcut all around of 10 mm. This is to prevent any collision later on. Since this is a quick and dirty process, it will leave a 10 mm extra on the stock. After that I do a 2D contour process to cut out the silhouette of the neck. I make large steps on a few points on the side to hold the neck in place when I flip the stock later. To make sure they are holding the whole neck when flipped, the tabs are quite large, 30 mm in height. The process will be performed in multiple depths of 3 mm and the bottom of the process is half a millimeter lower than the neck actually is, to make sure it's completely through. The stock material is 30 mm thick, while the neck has a final height of 25 mm, so after this contour process the neck still will be held firmly in place by the stock itself. A simple adaptive process is started to roughly remove material on the headstock. It will leave a half millimeter extra on. This will be removed by a more precise process, the parallel process. This will create the end result of the top side. It makes a long precise movements and takes off a half millimeter material in very small sideways steps. To create the slot for the truss rod, a contour process routes the needed depth. This is a simple process which only takes about 3 minutes. Now the holes are made for the tuners and screws in the neck. To make sure they are completely through, they go down also an extra half a millimeter. Then it's time to flip the whole stock, put 0 at the bottom, put the dowels into place and start with the other side of the neck. Again, I start off with a face process with an overcut on all sides. Then an extensive adaptive clearing process is started and each level goes down 5 mm and it works its way upwards in smaller steps. It leaves a half a millimeter material on. This will be removed later. Since this process creates a curvature on the neck, it takes quite some time. Now it's time for the more precise work. That is done by a parallel process, pretty much the same way as before, but this is only handling the middle section. The neck joint and backside of the headstock is a process later on, as well as the holes for the neck joint. I hope this is helpful. Please let me know if you have any questions or have a look in the description for a link to my website for more information. You can now watch the video of my CNC machine creating the neck. Here I'm securing the stock to the spool board by using 4 screws and determining the center point of the stock. Then I make the holes for holding the dowels when I flip the stock material later on. Now I'm placing back the stock again, nulling the Z-axis at the top of the material, and then it's ready to start the CNC program. It starts by drilling the holes for the dowels and then the facing process starts. I might adjust my step over next time, because I find that there is still too much material left after this process. Then the contour process takes place, clearing material on the side of the neck. Since this goes in steps of 3 mm and creates steps as well, it takes quite a while. The headstock is being made by the adaptive process. This goes quickly and rough. The parallel process is where the smooth finish comes from. Long processes in small sideways steps. It goes from neck joint all the way to the headstock, creating a smooth finish. Now the threshold slot is being made, as well as the holes for the tuners and the holes for the screws to hold down the neck to the guitar body. After some cleaning up and placing the dowels, it's time to nail the Z-axis again and start the process for the other side. Again, I'm securing the stock firmly into place and the facing process takes off. The adaptive process takes a lot longer now because the curvature is being made. The machine needs to take away a lot of material now. Also, because this is quite a rough process, I need to clean it a bit more now. The parallel process creates a nice smooth finish. This will only do the middle section, the rest, the headstock and the neck joint, will be done later. Here you can see the parallel process for the headstock. After the neck joint has been done, the holes for the screws will be made. Now what is left is some cleaning and some sanding and we're done with the neck. Hope this was helpful. Thanks for watching.